Welcome to our cosmic journey through the mysteries of the Milky Way. Today, we're diving into a recent astronomical discovery that's been baffling scientists and sparking debates: the eROSITA bubbles. What are they? Where did they come from? And what do they tell us about our galaxy's history? Stay tuned as we explore this fascinating phenomenon. In 2020, astronomers discovered an enormous hourglass-shaped structure near the center of our Milky Way galaxy. These intriguing formations, known as the eROSITA bubbles, were first detected by the eROSITA X-ray telescope aboard the Russian-German Spectrum X-Gamma Space Observatory, launched in 2019. These bubbles are not just any ordinary celestial structures. They are larger and more energetic than the previously discovered Fermi bubbles. While the Fermi bubbles were observed through gamma-ray and X-ray emissions, the eROSITA bubbles were detected via soft X-rays, highly energetic photons, yet less powerful than gamma rays. So, what makes these bubbles so special? Unlike the Fermi bubbles, which were observed through gamma-ray and X-ray emissions, the eROSITA bubbles were detected via soft X-rays, highly energetic photons, yet less powerful than gamma rays. This distinction has led scientists to propose several hypotheses about their origins and characteristics. One hypothesis suggests that these bubbles are massive structures, spanning about 10,000 parsecs, or roughly 32,600 light-years, blown by energetic events at the galactic center. Another hypothesis posits that they are much smaller structures, only about 100 parsecs or 326 light-years in scale, possibly located near our own solar system. The energy difference between these two scenarios is staggering, 3 to 4 orders of magnitude. To solve this cosmic puzzle, a team of researchers from China and Europe created a high-resolution map of the region. They discovered that two prominent features within the northern eROSITA bubble, the North Polar Spur, NPS, and the Lotus Petal Cloud, LPC, are not independent entities. Instead, they appear to be part of a single, giant bubble. This discovery was made by analyzing the three-dimensional shapes of dusty clouds in the Milky Way. By measuring the distances to these clouds, the researchers inferred that the bubbles must be located farther away, at least 1,000 parsecs. They also identified a shock front, emitting polarized radio waves, connecting the NPS and LPC, further supporting the idea of a single, massive bubble. This discovery was made by analyzing the three-dimensional shapes of dusty clouds in the Milky Way. By measuring the distances to these clouds, the researchers inferred that the bubbles must be located farther away, at least 1,000 parsecs. They also identified a shock front emitting polarized radio waves, connecting the NPS and LPC, further supporting the idea of a single, massive bubble. The team avoided focusing solely on the main body of the eROSITA bubbles and instead examined specific morphological features. Their visual methodology led them to conclude that the northern eROSITA bubble is a colossal structure rooted at the galactic center, likely caused by energy injections from powerful cosmic events. But what about the southern bubble? Its border is less defined due to fainter X-ray emissions and complex features seen in the radio spectrum. It appears more elongated and less inclined than its northern counterpart, leaving some uncertainty about whether it fully closes into a bubble or remains open. This groundbreaking research not only sheds light on the enigmatic eROSITA bubbles, but also highlights the importance of innovative approaches in astronomy. As lead researcher Teng Liu stated, "To solve a problem, what one needs is not necessarily a doctor's degree, but an idea." The eROSITA bubbles are larger and more energetic overall than the Fermi bubbles, with quasi-circular lobes above and below the plane of the Milky Way, with two prominent features in the northern bubble: the North Polar Spur, NPS, and the Lotus Petal Cloud, LPC. On a two-dimensional X-ray map, these appear as two separate features, and they could be two distinct three-dimensional structures that by chance make up a two-dimensional bubble. There have been two contradictory hypotheses to explain the eROSITA bubbles: either a 10,000 parsec scale pair of giant bubbles blown by the galactic center, or a 100 parsec scale structure in the region of the Sun, coincidentally located in the direction of the galactic center. 1 parsec is 3.26 light-years. The three-dimensional structure of the eROSITA bubbles is unknown. As two-dimensional, they appear as possibly the shadow of some other phenomenon. The energy involved in these two pictures differ by 3 to 4 orders of magnitude, said Teng Liu, an astronomer at the University of Science and Technology of China in Hefei and lead author of the new study. Thus, the solution has important consequences on the structure and history of the Milky Way. While astronomers have been unable to determine the distance to the X-ray emissions of the eROSITA bubble, they have measured the distance to dusty clouds that are part of the Milky Way. An earlier study led by Liu did find 3 isolated dusty clouds at a distance of 500 to 800 parsecs, whose shape perfectly matches the X-ray shadows on the eROSITA bubbles, implying that the bubbles are more distant still. A shock front emitting polarized radio waves connects the North Polar Spur and Lotus Petal Cloud. That work also found that the outer border of the northern eROSITA bubble can be easily explained as a skewed three-dimensional model rooted at the galactic center, and concluded that the scale of the eROSITA bubbles is about 10,000 parsecs, established at the galactic center. To settle this matter of perspective, Liu and his teammates avoided analyzing the main body of the eROSITA bubbles. They focused on the question of whether the bubbles are a giant, distant bubble or a small structure near the sun. Instead of quantitative calculations, we simply pick up a few morphological features by eye, said Liu, whose existence makes a strong point to answer the question. In particular, from the projected shape of the three-dimensional dust clouds, it was possible to conclude that the NPS and LPC were distant, at least 1,000 parsecs away. Radio emission arcs were found in the dark region between these two features, dark meaning an absence of X-rays, and were attributed to the shock wave of the bubble's front. Matching the outer border of the NPS and LPC provided a way to determine the northern bubble's border. This definition of the border can easily be described as a tangent to a line of sight of the three-dimensional cup model rooted in the galactic center. From this, the group concluded that the NPS and LPC were not independent, distant features, but made up of a single, giant bubble. They determined that the northern eROSITA bubble is most likely the 10,000 parsec bubble, with its root at the galactic center, blown by energy injection. The border of the southern bubble is not as cleanly defined as the northern bubble, due to fainter X-ray emissions and some complicated features seen in the radio spectrum. It seems more elongated and less inclined than the northern bubble. Hence, it cannot be determined if the southern cup mentioned above is open or if it truly closes off into a bubble. The relative simplicity of the visual methodology used shows that Liu said, to solve a problem, what one needs is not necessarily a doctor's degree, but an idea. This groundbreaking research not only sheds light on the enigmatic eROSITA bubbles, but also highlights the importance of innovative approaches in astronomy. As lead researcher Teng Liu stated, to solve a problem, what one needs is not necessarily a doctor's degree, but an idea. So, what does this mean for our understanding of the Milky Way? These findings suggest that our galaxy has undergone incredibly energetic processes capable of creating massive bubble-like structures. This discovery challenges our current models and opens new avenues for research into the history and dynamics of our galactic center. As we continue to explore the cosmos, each new discovery brings us one step closer to unraveling the mysteries of the universe. The eROSITA bubbles remind us of the vast and dynamic nature of our galaxy, urging us to keep looking up and asking questions. Thank you for joining us on this cosmic journey. If you enjoyed this video, don't forget to like.